In this video, we will look at piecewise defined functions. So look at this example. If I give you f of x is equal to something like this. So f of x is comprised of two separate functions. In the first, for all values of x less than 1, it takes the form f of x equals 2/3 x plus 1. For all values x greater than or equal to 1, it takes the form f of x equals negative 2x plus 1. So you can think of it as two separate functions existing together in different parts of the domain. So the first question is, find the values of f of 0, f of 1, and f of 2. Now, in order to do that, you have to know which function you need to use to evaluate, correct? So the first input is 0. Now look at it. 0 belongs in which interval? Is 0 less than 1 or 0 greater than or equal to 1? Obviously 0 is less than 1. That means the function that I will use to evaluate f of 0 will be the first function, because that's where I have my domain. So this is 1. So f of 0 is 1. So I mean that's the interval in which 0 belongs. Okay. Likewise, let's look at f of 1. Now where does 1 belong? 1 is not less than 1, but 1 is equal to 1, right? So that means I use the second function. So evaluate that by using the second function. So you have negative 2 plus 1 is negative 1. So my answer is f of 1 is negative 1. Now the third part is f of 2. 2 is obviously greater than or equal to 1. It is greater than 1. So I use the second function. So I get f of 2 is negative 3. Okay, and that's how you evaluate, by first determining which of the two functions I'm going to use depending upon where the x value lies, and then I substitute and find it. So the second part of the question is asking me what is the domain. So to find the domain, look at the two intervals given to me. In the first interval, so if I have my number line, let's say, and this number line is all the x values, right? So the first interval takes care of all the x values less than 1. The second interval takes care of all the x values 1 or above. So between them, the entire number line is taken care of. So my domain will be all real numbers. Okay. In the third part of the question, I'm asked to locate any intercepts. So any intercepts meaning x-intercept and y-intercept. Now let's recall. For any function, how many y-intercepts can it have? Only one. And where will that y-intercept happen? When x is 0, right? So go to these two functions given. Which function has an x value of 0 included? The first function. So if I'm trying to find out my y-intercept when the x is equal to 0, I have to use my first function. But look at this, I have already evaluated it. I already know what is f of 0. It's 1, right? So I know f of 0 is 1. So that means my y-intercept is 1. So 0, comma 1 is the y-intercept. Straightforward, no problem. However, to find the x-intercept, because a function can have more than one x-intercept, we have to see a couple of things, right? So the first thing I will do is, to find the x-intercept, I have to set the y equal to 0 or f of x is equal to 0. But what I need to do is, I have to do this for both pieces of the function. It's not enough if I did for one, I have to do for both. So I'm going to solve. So I solve this. This is what I get, my first value. Then I solve this. I get this as a second value. Now, does this not automatically mean that there are two x-intercepts, right? So x equals -3/2. I had to make sure that x equals -3/2 actually belongs to the domain of the first function. Now, does it? Is -3/2 less than 1? It is, isn't it? Isn't it? Isn't -3/2 less than 1? It is. So that means this is going to work for me. Now look at the second one. X is half. Is half greater than 1? No, it's not. So that means this x value cannot be an intercept because this point 1/2, 0 does not exist, right? It is not part of, because we use the second function, but half is not part of the second function's domain. So that means my function has only one x-intercept, and that x-intercept is -3/2, 0. Now let's use all of this information to graph this function. So when you graph a piecewise function, the first thing that you will do is, how many functions are you graphing? You're graphing 2 in this case, right? And where is it getting divided? It is getting divided at an x value of 1. That is what this question has, right? Your different piecewise function can have a different scenario. So this one has this as its scenario. So 1 is where it is getting split into 2 halves. So this is not an asymptote. I'm just drawing this as a marker for myself. I can erase it later on. So the first part of the function, all values of x less than 1, the function takes the form f of x equals 2/3 x plus 1. Towards the right of this, it takes the form f of x is equal to -2x plus 1. I need, these are both straight lines. I need 2 points to draw a line. That's it. I just need 2 points. Now you can use the intercepts that you already calculated. Let's see whether we can use them. You know that f of 0 you calculated earlier, and f of 0 was 1, and 0, 1 is a point. So 0, 1 is a point. So that is a very easy point to mark. Right? But that's not enough for me. I need one more point. And the point that I'm going to use is, where is this? So in the first one, what happens? So remember, this x value is 1, right? So what happens when x is 1? So if I plug x equals 1, right? If I evaluate f of 1, I get 2/3 times 1 plus 1. That is 1 and 2/3, which is 5/3, right? So 5/3 is somewhere here. But this point is not on the graph of the first function. It's not, because the first function, all values of x only less than 1, not x equal to 1. So that is cannot be used. But this x-intercept can be used, -3/2, right? So that is on this graph. So that is somewhere here. So now I have 3 points. I connect them. Draw an arrow. That's my first piece. Now let's look at the second piece. For the second piece, I so far don't have any points, so I have to calculate. What is the first point I'm going to calculate? This x value where I'm splitting the two graphs, which is the 1, right? So I'm going to calculate f of 1. So what is f of 1? F of 1 is -1. So 1, -1 is a point on the graph. So let's say this is that point. Now I use a closed circle here because this is actually a point on the graph, because 1 is in the domain of the second function. I need one more value, right? So I can plug in anything I want. Yeah. So I'll do 2. So then I have negative 2 times 2 plus 1. So that is negative 3. So I have 2 comma negative 3 is somewhere here. So then my graph goes this way. Because this has a negative slope, it goes this way, right? So this is my piecewise function. At this point, I can try to erase this dotted line that I drew. Oh, so this one is 1 comma 5/3, but this point is not on the graph. Whereas this point, 1 comma negative 1 is on the graph. So this is my piecewise functions graph. Now, if I use this graph to find the range of the function, what is the range of my function? You see that the range goes from all the way from negative infinity. It stops here at negative 1, but this graph picks it up all the y values. But the highest y value that here is 5/3, right? But 5/3 itself is not included. So this will be my range. So 5/3 is not included, but all the values go up until then. So that will be the range of the function. All right. So now let's do another example where we work backwards to find the function from a graph. So in this example, I'm going to come up with a graph. Let's see what I come up with. What graph can I come up with? Hmm. Let's say this is my graph. Okay, let's label some points. I don't know how this is going to work out. I'm just coming up with this. So let's say this is negative 2, 0. And let's say this is 2, 4. And let's say this is 4, 4. And let's say this is, it looks like 6, 0 or something like that. Okay. So now here, I can think of this as 3 pieces, right? So if I were to look at my number line, this number line, all of these x values up until here is one function. Then I can think of this as starting from positive 2 to 4 is one function. And then I can think of it as 4 to positive infinity is a third function. So I can split it up into 3 functions. So let us see what is the equation of the first function. So the first function is a straight line. I have 2 points on the straight line, so I can find the slope. What is the slope? y2 minus y1 over x2 minus x1. So 4 over 4, 1 is the slope. So then how do I write the equation? I use the point slope form and I say y minus y1 is mx minus x1. The point I'm going to use is -2, 0, right? So y minus 0 is 1 times x minus -2, which is 1 times x plus 2. So y equals x plus 2 is the equation of the first line. So now let's see the equation of the second line. The second line is a constant, correct? So all the y values are 4. So this equation is pretty straightforward. Y equals 4 is the equation of the second line. Third line is another slant line. The slope is y2 minus y1 over x2 minus x1. So -2 is the slope. Now to write the equation, I do y minus y1 is mx minus x1. The point I'm going to use is 6, 0. So I have y minus 0 is -2x minus 6. So y equals -2x plus 12 is the equation of the third line. So now let's put this together. So how is my function going to look like? F of x has 3 parts, correct? The first part, what is the domain of the first part? The first part is all the x values less than or equal to 2, right? That is the first part. Second part is between 2 to 4, but remember, 2 cannot belong to both the first and the second function. It can only belong to one or the other. Now, since we already gave it to the first function, this cannot be included in the second. But 4 can be included in the second or third. So let's see that I put it in the second. Now the third function starts at 4, but again 4 cannot be included because 4 was already used up before, right? So it starts at 4 and it goes all the way to infinity. So all values greater than 4. And we already wrote the functions, right? So what is the first function we wrote? We wrote it as x plus 2 if x is less than or equal to 2. 4 if between 2 and 4. And -2x plus 12 if greater than 4. And that's it. And that is our piecewise function.